Dear students, in the last lecture we have studied about the hybrid parameters and the equation corresponding to hybrid parameters. The equation corresponding to hybrid parameters are given by V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. Through this lecture you are going to study about the condition for reciprocity in terms of hybrid parameters. So I am taking the same set of equations here. Here, consider a two-pore network. You need to check for reciprocity. So, this is a two-pore network. I will be having my I1 here and V1 at this spot and I2 here and V2 at this spot. Okay, so this is a representation of a two-pore network. Now, you need to check for the condition for reciprocity. So, we know that according to reciprocity theorem, a network is said to be reciprocal if the ratio of excitation at one port to the response at the other port is same if the excitation and response are interchanged. Okay, so in the first case, I am going to take V1 is equal to Vs. Okay, that means I am going to connect my source or excitation at the input side and I am making the output side as short circuit. That means V2 is equal to 0. Okay, so first case is I am connecting the excitation or source at the input port and output port is short circuited. Okay, so let I2 dash be the current here. I can write the condition as V1 is Vs and my V2 is equal to 0. And I2 is equal to minus I2 dash. Okay, so these are the conditions if I am connecting the source at the input port and short circuiting the output port. Okay, so if I am substituting these conditions in these equations, I can write V1 is equal to H11 I1 plus H12 V2 is 0. Okay, and here I know that my Vs is equal to V1 is actually Vs is equal to H11 I1. Okay, now if I am considering the second equation, from the second equation I can write I2 is equal to H21 I1, or from this equation I can write I2 is actually minus I2 dash. So minus I2 dash is equal to H21 into I1. So from this equation, let it be equation number A and let it be equation number B. From A and B, I can find the ratio Vs by I2 dash is equal to minus of H11 by H21. Okay, so the ratio of excitation to the response at the input response when we are connecting the excitation at the input port is Vs by I2 dash is equal to minus H11 by H21. Then take case 2. In case 2, what is happening is I am taking the same two-port network and I am connecting the source at the output side. So here I have the source V of S and the current flowing is I2 and the input source I am short circuiting. So here I have the current I1 dash and here I have the current V1 and I have V1 is equal to 0. So the conditions here are V2 is equal to Vs, V1 is equal to 0 and I1 is equal to minus I1 dash. So if I am connecting the excitation at the output side and taking response from the input side, I have the conditions V2 is equal to Vs, V1 is equal to 0 and I1 is equal to minus I1 dash. If I am substituting the same conditions in this set of equations, from the first equation I can write V1 is 0, so therefore 0 is equal to H11 I1 plus H12 V2. Or I can write, I know I1 is minus I1 dash and V2 is Vs. So I can write H11 into I1 dash is equal to H12 into V2. Or I can solve for V2 by I1 dash is equal to H11 by H12. Okay, so this is the case. This is the ratio of source to the excitation. Actually V2 is Vs. Source to the response, not excitation, source to the response. When I am connecting the source or excitation at the output side and taking response from the input side. Vs by I1 dash is equal to H11 by H12. Okay, so in order to make the system a reciprocal, or in order to make this network a reciprocal network, Vs by I2 dash should be equal to Vs by I1 dash. So we know that Vs by I2 dash is minus H11 by H21 and Vs by I1 dash is H11 by H12. If these two ratios are equal, I can write my H21 as equal to minus of H12. Okay, so what is the condition of reciprocity in terms of H parameters is H21 is equal to H12. Okay, so this is how you can find or you can check whether the given system or given network is reciprocal in terms of H parameters. Solve for H21 and solve for H12. If H21 is equal to negative of H12, then the network is said to be reciprocal. Next, you have to study about the condition for symmetry. Okay, so we know that for a network to be symmetrical, the voltage to current ratio at one port should be the same as the voltage to current ratio at the other port, with one of the ports as open circuited. That means if you are connecting the source at a particular port and making the other port as open circuit, then you are finding the current to voltage ratio at the particular point, then interchange the conditions and again find the ratio between current to voltage at the other port, then both should be equal. Okay, so here also we are going to perform the same thing, but here we can go in another method. We know that from the Z parameters, I have my Z11 is equal to V1 by I1, and this is obtained by making I2 is equal to 0. Okay, Z11 is V1 by I1, that is equal at I2 is equal to 0. So I know that from the H parameter, V1 is equal to H11 I1 plus H12 V2. Okay, so I can write this as equal to, this particular equation is equal to H11 I1 plus H12 V2 divided by I1 at I2 is equal to 0. Or I can solve this as H11 plus H12 into V2 by I1. Okay, if I'm making I2 is equal to 0, again I'm getting Z11 is equal to H11 plus H12 V2 by I1. Okay, but we know that I2 is equal to 0. Okay, I2 is equal to 0. So from this equation, if I am taking I2 is equal to 0, I have H21 I1 plus H22 V2 is equal to 0. Or I can write, from this equation I can write V2 by I1 is equal to minus of H21 by H22. Okay, V2 by I1 is equal to minus of H21 by H22. Now, if I am substituting this in this particular equation, I can write Z11 is equal to H11 plus or minus H12 into H21 by H22. Okay, Z11 is equal to H11 minus H12 into H21 divided by H22. Or I can write like this is equal to H11 H22 minus H12 H21 divided by H22. Here you can substitute this term H11 H22 minus H12 H21 is equal to delta H by H22. Why it is delta H is, you have the hybrid parameter matrix as equal to H11, H12, H21, H22. So if you are finding the determinant of this matrix, that will be H11, H12 minus H12, H21. Okay, so that is the term here, H11, H22 minus H12, H21. That is why it is not designated as delta H by H22. Okay, so that is the condition. So here Z11 is obtained as delta H by H22. Now you have to take the equation corresponding to Z22. Z22 is actually V2 by I2 at I1 is equal to 0. Okay, when I am making I1 is equal to 0 from this equation, when I am making I1 is equal to 0, I am getting I2 is equal to H22 into V2. Okay, so if I am making I1 is equal to 0, I can write I2 is equal to H22 into V2. H22 into V2. Now, so what is I2 is H22 into V2. So from this, if I am substituting here, I can write Z22 is equal to 1 by H22. So what is the condition of symmetricity in the case of Z parameter is Z11 is equal to Z22. Okay. The condition for symmetricity in the case of Z parameter is Z11 is equal to Z22. So what is Z11 is? Z11 is delta H by H22 and Z22 is 1 by H22. That means if this condition should be satisfied, then I can write delta H by H22 is equal to 1 by H22. That means what? That means delta H is equal to 1. If delta H is equal to 1, I can write H11 H22 minus H21 H12 is equal to 1. That means the determinant of the hybrid matrix, if that is equal to 1, then the system is symmetrical. Okay, the determinant of the H matrix, that is given by H11 H12 H21 H22. The determinant of hybrid matrix delta H is given by H11 H22 minus H21 H12. If the determinant is equal to 1, then the system is, or then the network is said to be symmetrical. Okay, so that's all with the condition of reciprocity and symmetricity. Thank you.